Hello. So I'm going to be talking about the current state of AI agent security. And as the previous talk mentioned, this is more focused on looking at prompt injection robustness. And hopefully I can offer some additional perspectives to this. Obviously, we have agents deployed today, and these are growing in capabilities, and the risks are increasing with capabilities because they're taking actions in the real world. And obviously, we know that these are models are prone to jailbreaks, but right now they're incorporated into applications where there's prompt injection attacks. So here's what we want to evaluate. How do we do this properly? In fact, it's actually non-trivial. We have benchmarks in place. For instance, agent harm or harm bench or WASP and other benchmarks. But I think there are two problems. One is that these tests are static. The behaviors are already defined in the benchmark, and these are not updated throughout time. Problem two is that the attacks aren't adaptive. With all security measurements, I think one needs to be really careful about how to make the attacks adaptive in order to really be able to test the security of systems. And unfortunately, these two problems would actually give you a false sense of security, even if you're doing well on these benchmarks. This is where Gray Swan Arena comes in. This is currently the largest public red teaming, AI agent red teaming platform in the world. And we host periodic competitions and pre-release models in order to test their security against essentially the whole world of red teamers. Anyone can join, and they can find vulnerabilities and report them. And here we're trying to understand the question, how bad is it really? So we ran this is earlier in the year called the Agent Red Teaming Competition. It was supported by a lot of the Frontier Labs and UKAC and so on. Here's the setup. We deployed 50 agents, and these are the things that people actually use in daily life: sales agent, financial assistant, HR agent, marketing, code gen, shopping, email agents, and so on. And we used models from 10 different Frontier Labs. More than 100 different policies. So each agent would have its own set of policies tailored to its deployment. So this includes data policy, for instance, not leaking your company data, or discount policy for your support bot, and so on, developer policy, child policy. And these are policies that the agents are never supposed to violate. And the red teamers are trying to elicit violations from these agents. Ran this for a month, gathered more than 2 million chat attempts. And here's the upshot. Agents can completely compromise security. In fact, we had a 100% success rate on all the agents. Doesn't matter what base model you use. Doesn't matter what policy you're targeting. Tons of violations. And this is totaled 60,000 policy violations. And this is one policy violation in 25 chats. This is nowhere near the level of reliability that we want. High transfer rate, 15 to 50% transfer rate, depending on the model. So this means if there is a prompt injection that works in the wild, it probably affects your AI agent deployment as well. So we had this leaderboard. Obviously, this is from earlier this year. We have actually a new challenge, new arena challenge that's currently running. And just quickly go through some of the examples. Here's copyright violation, PII leakage, and this is very important for enterprise deployment. And this is essentially just the model posting your password on Instagram. Malicious code, right? If you're using a coding agent cursor, if you hook it up to web search and there's a prompt injection, then it could, for instance, make all your directory public or maybe even erase your home there. And we've seen fraud, data tampering, all sorts of violations. This is a 2D visualization of all these successful attempts across all the behaviors. And this is a pretty nice picture. And if you zoom into some of these sub-galaxies, then you can actually analyze the strategies that people use to break these agents. And this is data that is not in any of the static benchmarks right now. And this is super valuable data in order to have real-life adaptive attacks against the agents and looking for the vulnerabilities. And these actually transfer to production systems which is surprising. And this is still happening with the current models. And one thing I'll add, I think some of the recent models are making incredible progress on such benchmarks. And I think I'm generally hopeful for resolving these problems, but I think there's a lot more work to be done. Thanks, everyone.